velocity is high. V equals what? Can we say the kinetic energy of the bullet, which contains the V we're looking for, will equal the potential energy to which the block is raised? If so, that would be simple, and we could say kinetic energy of the bullet equals potential energy of the block. And 1/2 m big V squared equals m plus m, the both m's, times gh. You can say that solving for V is easy enough, but we can't go that route. Why? Because the kinetic energy of the bullet does more than raise the block, much more. The high-speed bullet appreciably heats the block while it slams to rest inside. You wouldn't want to put your bare finger into the bullet hole of the block before it cooled. So our energy equation would be kinetic energy of the bullet equals heating of the block plus the potential energy of the block. We don't have information that deals with the heat generated. That being the case, we move to the conservation of momentum. Well, this is a collision problem that bypasses heating or other forms of energy. By that we mean that the momentum of the fired bullet before colliding with a block equals the momentum of the block with its embedded bullet immediately after the collision, regardless of any heat generated. Heat is an energy thing, not a momentum thing. So we write this as mv equals big M times m times little v, where little m is the mass of the bullet, big V is the bullet's velocity, what we're looking for, big M is the mass of the block, and little v is the velocity of the block with the bullet immediately after collision. So, we see that big V equals the sum of the masses over the little mass times little v. Problem solved? Not quite. We don't know the velocity of the block with its embedded bullet. That's the small symbol v. The equation tells us that we must find v. But how? Aha, we switch our attention to the conservation of energy. Why? Because the kinetic energy of the block, whether heated or not, transfers to potential energy. So the initial kinetic energy of the block upon absorbing the fired bullet will equal the potential energy of the block at the top of its swing. We write this as kinetic energy bottom equals potential energy top, or 1/2 mass combination times little v squared equals mass combination times gh, where g is the acceleration due to gravity and h is the measured height to which the block rises. And guess what, folks? The v in this equation, the initial velocity of the block, is what we're looking for. Solving for v, we find taking the square root of both sides and solving for v only leads us to v equals square root of 2gh. Aha, is this fun or what? Now we substitute this in our equation above. Now our problem is solved, for all the symbols represent known quantities. We know the masses and the height the block rises. You may do this in lab. Then you can put numbers in. In my experience, the raw physics is best seen with its symbols. Solving problems with symbols only may take a bit of getting used to if all the problem solving you've had in the past was numerical. Are we learning? That's the most important thing. Let me leave you with this question. If the same mass bullet were fired at twice the speed into the block, how much higher would the block swing? Until next time, good energy.